Hey, what's up, you guys? Do you like this effect? It's pretty cool. It's Mimikyu here, and I'm gonna be doing. Did you hear my shoulder crack? I'm gonna be doing ASMR reading of some AP Stats interpretations to help me study. So I tried filming this, got a little bit of way through it, so I'm gonna start probably through. So we were actually just going over this today. We did a Desmos on it, and here how to describe a distribution. So be sure to address shape, center, variability, and outliers in context. Make sure to include that context, because if you don't include the context, it's nothing. It's worthless. So they don't tell you. Gotta have the context. So here's an example. And so it's pretty. Example. The distribution of student height is unimodal and roughly symmetric. So unimodal means that if you're looking on the graph, right, there's just one place with a lot, like with the majority of the data, so like the mean or like the median. There's just like one area where there's most of the data, but sometimes there's two areas where there's most of the data. Let's say you're on a graph. This is your graph, and then it goes up and then up again. With like there has to be like a gap in it. If there's like a gap in the middle, then that will be bimodal. So this one's unimodal and roughly symmetric. Roughly symmetric means that both sides are like the whole thing, like it's kind of balanced. So like let's say it's bimodal, one of them is a lot higher than the other, and if roughly symmetric is usually in opposition to skewed, and skewed means there's a lot more data on one side than there is on the other, and the way that it's described is kind of confusing. Right skewed means actually that there's more data on the left side, and left skewed means actually there's more data on the right side. But the way that you remember that, well, the way that I remember it, that like my stats teacher told me, was you think about like your feet and how your toes go, because on your left foot, your toes go from smallest to biggest this way, and so that's what I always think about. The mean height, you guys know what I mean. The center can also, it can be the mean, or if there's a lot of outliers, you can use the median, because the median is not affected by outliers. And a standard deviation of 8.2 inches. There is a potential upper outlier. Ooh, spicy. So do you guys know, you probably do, but the rule for outliers is, I should have a clip around here somewhere. Anyway, the rule for outliers is that it has to be 1.5 times IQR, and then if you're doing low outliers, it's 1.5 times IQR minus Q1, and then if you're trying to do high outliers, it's 1.5 times IQR plus Q3. Yeah. So you're gonna check for those, and a gap. So it's just like if there's anything unusual, a gap between 60 and 62 inches. So like if we're looking at a distribution and there's like an area where there's nothing, that could be something unusual. So that'd be like a gap. Okay, so that's it for unit 1. So we can move on to unit 2. So unit 2 is exploring. I don't really feel like I'm exploring. More like I'm, just kind of going in. I mean, it's sort of exploring. I don't know. Exploring 2 variable data. So not just 1, 2. The first one we got on here is correlation, R. This one's an important one. But usually what they give you on the, because computer printouts, usually what they give you is R squared. So, and then you have to find R by taking the square root of R squared, which is like really easy, so I don't really understand why they do that, but they do. The linear association between X context and Y context is weak slash moderate slash strong. So you describe the strength and then you describe the direction, so positive or negative. The example here is the linear association between student absences and final grades is fairly strong and negative. So the R there is, you're definitely not going to be able to see this. The R there is negative 0.93. So definitely negative and definitely fairly strong because it's pretty close to -1. So then we got the residual. And the residual is like, so you use the like prediction to predict a value, and then there's like an expected value and there's actual value. So you subtract the actual value from the expected value, and then you get a residual. And then to interpret the residual, you go, the actual Y context was residual, so the like value above slash below the predicted value when X context equals number. So above, below, again, depends on if it's positive or negative. So the actual heart rate was 4.5 beats per minute above the number predicted when Matt ran for 5 minutes. So that was probably a positive 0.45 because it's above. So then we have the y-intercept. This one's really easy to remember because it's usually when there's just a graph, you can just kind of like see it. So the predicted y context when x equals 0 context is y-intercept. So like the predicted time to check out at the grocery store when there are 0 customers in line is 72.95 seconds. So this is basically like when x equals 0, what is the thing? And sometimes it's like doesn't make sense because there's not a time when it'd be 0. So it's like if you when your height is 0 inches, you're weighed this much. But that wouldn't make sense because no one's height is 0 inches. Everyone has like a certain amount of height. So I kind of look like I'm in heaven in here, like just light blasting through the windows. Okay, I'm gonna try not to take this too long, so I don't know if I'll get through all of these. But oh wait, let me show you guys my binder. This is my binder where I keep all my stat stuff. And it has a collage on it that I made. And there's like frog, man, this is a sticker, M for Mimikyu, and lots of other cool stuff on here. The inside subject matter is also pretty cool. Oops, by flag. All my stats work from the whole year, which is significant. That's all just like papers, like Statsmatic papers. I don't know why they keep them all with me, but I'm just like, what if I need them? Anyway, moving on to slope. So the predicted y context increases / decreases by slope for each additional x context. So increases and decreases again will be if the slope is positive or negative. So like the predicted heart rate, it's the y context, increases, so I'd say it was a positive value, by 4.3 beats per minute, so that's the x context, for each additional minute jogged. And then we have more stuff about residuals, but this is the standard deviation of residuals, and this is represented by the symbol S. So the actual y context is about S, that's the standard deviation of residuals, away from the value predicted by the LSRL. The LSRL is the least scored regression line, if you guys didn't know that. So like the actual SAT score, they like to talk about SAT scores a lot, but I guess that's like pretty important data. So it's typically about 14.3 points away from the value predicted by the LSRL. That's 10 minutes, so I'm gonna cut it off there because I don't want you guys to have to watch a video that's too long. But I hope it was helpful, or that it was nice to relax to, or fall asleep to, or listen in the background. And let me know if you guys want to do, if you guys want me to do more videos like this, related to AP stats or other kinds of videos, or if you have any requests or anything. Sorry again about the noise in the background. Have a good night or day, or whatever you're having.